All right, so let's suppose I want to, let's say we have this, I found out the sequence, and it is, let's say 3n, right? 3n. So in other words, if I have a set of numbers like 3, 6, 9, 12, and so forth, we know that this is 3n, isn't that so? Because the first term here is 3, which is 3 times 1. Second number here is 3 times 2, 3 times 3, and then 3 times 4. So we realize we're going up in sequence by 1. So we know, and this is constant. So this is a constant 3 multiplied by 1, 2, 3, 4. And of course, is the first term, second term, third term, fourth term. So I can use n as a position of the term. This is the first term, which is 3. Second term, which is 6. Third term, which is 9. And fourth term, which is 12. I'm not saying 4 here is the position of the term itself, but we can use it as a position of the term. So in other words, 3n would be the formula for all of this, because when you put 1 here, the first term, and you put 1, is 3 times 1 is 3. All right, you put 2 here, 3 times 2 gives us 6, which is second term. When you put 3, which is the third term, you get 9. Fourth term, put 4 here, you get 12. So it actually works as 3n. Now what if I want 3, negative 6, positive 9, negative 12? So I want to be alternating as positive, negative, positive, negative. What I would need to do is to multiply 3n by, I want to use this. I would multiply 3n by negative 1 to the n power. So all this does, it doesn't affect this term here. It doesn't affect the value, well, it doesn't affect the size of the numbers in terms of 3, 6, 9, and 12. What will change is the sign of the numbers, because this is an alternator. Think about it. When I put 3 times 1 here, I'll get my first term, which is 3, right? But when I multiply by negative 1 to the 1 power, this will become negative 1. So this will be actually negative 3. But we don't want negative 1, positive 3. So what I'll do, I'll add a 1 here, right? I'll add a 1 here. So it's actually negative 1 to the n plus 1. So instead of being just 1, it will be 1 plus 1. And so I'll have negative 1 to the second power, which is going to make it a positive, because square of negative 1 is 1. So in fact, I'll have the 3 here being multiplied by 1. So regardless of the numbers I put, this will always be the same. 3 times 1 is 3. When I put the 2, I'll be 3 times 2 is 6. When I put the 3, 3 times 3 is 9. When I put n being 4, 3 times 4 give me 12. But what happened? N here will also be changing simultaneous with this n. This n will be changing with this n. So as you can see, when n is 1, as in the first term, right? I put n to be 1, it gives me 3. But this becomes 1 plus 1, which is 2. And the square of this will be 1, positive 1. So 1 times 3 is 3, which is a positive 1. Let me show you. If I put negative 1 and I put n plus 1, which is just an alternator. This is just multiply by negative 1, multiply by positive 1, multiply by negative 1, and so forth. When n is, let's say, the second term, right? So n will be 2. Right? So we put negative 1, 2 plus 1, 3 times 2. If you notice, I get the same 6 here, right? As I work it out, right? This will be 6. However, this will be actually negative 1 times, negative 1 to the third power, which will be negative 1 times negative 1, negative 1 will be negative 1 times 6, right? And that will be negative 6. So it actually alternates this. And if we keep on doing it, we'll actually have negative 6, positive 9. All right, let me show you. If I have negative 1, and this is the third term, so it'll be n plus 1, or this will be a 3 in this case. So 3 plus 1, right? Remember the third term, first, second, third. So the n will be a 3. Remember, it's n plus 1 we're using and not just n. And then the n here will actually be, we're looking at first, second, third term. So we'll end up with negative 1 to the fourth power. And 3 is 9. And this will be negative 1 times negative 1 times negative 1 times negative 1, which will be positive 1 times 9, get a positive 9, as you can see. And when it's when it's the fourth term, be 4 plus 1, which is 5. So 5 to the negative 1 to the fifth power will be a negative 1. Multiplied by the 12, it will be negative 12, and so forth.